Yes guys, we've got a logic question from James Chen's paper 2, TMUA. So we've got 5 people in a room. They've given us 3 statements about probabilities. So the first one reads, probability that at least 2 of them share a birthday is P. The probability that James shares a birthday with someone else in the room is Q. The probability that no 2 of them share a birthday is R. Which option gives the correct inequality regarding P, Q and R? Well, with this one, I think there's a clear greatest probability, which is the third statement, which is R. Why is that? Well, the probability that no 2 of them share a birthday. Right, let's have a think. That no 2 of them share a birthday. So what's the probability of 2 people sharing a birthday? 1 over 365 times 1 over 365, which is 1 over 365 squared, which is insanely small. So if this is the probability that 2 of them share a birthday, the probability that none of them is just 1 minus this, which is quite close to 1, which is just approximately 1. And compared to the other 2 probabilities, so P, the probability that at least 2 of them share a birthday, this is obviously going to be much more. So we can eliminate ones where R is not the greatest. So get rid of B, C, E and F. So all we're left with is A and D, and we just need to compare P and Q. So let's have a read of them again. The probability that at least 2 of them share a birthday. The probability that James shares a birthday with someone else. Essentially, these 2 statements are telling us similar things. The probability that James and someone else is, you could say, a smaller case of the first statement, because this is the case where James and one other, let's call them person A, shares a birthday, and this is the probability that 2 of them share a birthday. So that can be let's say person 1, 2, person 1, 3, person 1, 4, person 1, 5, 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, and 4, 5. And let's say, I don't know, James is person 1. Well, that's the probability of 1, 2, 1, 3, 1, 4, 1, 5. So it's obviously, if we see the probabilities of all these events happening, so 1 and 2 sharing a birthday, or person 1 and 3 sharing a birthday, this means that P is obviously greater than Q. And yeah, from that we can just conclude that Q, like the event of Q happening, is sort of a subset of event P. So that means Q must be less than P. So we can say A can go, and D is our correct answer. So there wasn't much maths involved in that, a bit of counting, a bit of common sense and logic. So that's all. First logic, which we've had a few logic problems on the channel, but first in a long time. So that was fun and easy, nice stuff.